Here's a quick look at that number 15 from homework 4 and 5. There's a little tricky pieces to it, the derivative itself. I know where a common error can come up, and I can certainly make that error on a regular basis. But first, you got to rewrite that first part of that function even before we can take the derivative. So if you'll notice, you got to have, you have to know that that cube root is the same thing as a 1/3 power. So if I'm taking the cube root of x squared, it's actually x squared to the 1/3. Power over power, you multiply them. So 2 times 1/3 is 2/3, and that's where I've stopped. You can see right there. Then the next piece is I don't want that x, I want it to be 4x to some power, and so I need to move that x up to the top, and that means a negative exponent. So that means 4x to the negative 2/3. And that's just the first part of it, so don't forget to put the minus x back in there. I would easily forget that. Now we can take the derivative with the power rule, and that will give us the slope we need. We need the derivative in order to get the slope of the tangent line, which is what the direction's asking for. So I'm getting the derivative right now with the power rule. I did the power multiplied out front, and so I'm taking that negative 2/3 times 4. That's negative 8/3, and then now I'm doing negative 2/3 minus 1. But I just want to be really careful how I do that. When I do it as 3/3. And so you can get that power easily. And then don't forget the derivative of minus x is minus 1. So that's down below. I'm going to simplify the fraction in the up top here, kind of clean things up. And so that's negative 5/3. And don't forget the minus 1 at the end. It's so easy to forget that, so look out for that. Now we're actually going to put negative 1 in there because we're looking for the slope of the tangent at the point negative 1, 5. And the derivative allows us to find the slope there for that tangent line with plugging in the x-coordinate, negative 1. So I plugged it in. You can either use your calculator or do it by hand, but negative 1 to negative 5/3 actually just ends up being negative 1. If you take a negative to an odd power, and negative 5/3 counts as an odd power, you get out actually negative 1, the same thing. And so the two negatives make a positive, and that's 8/3 minus 1, which is like 3/3. So that'd be 5/3 total, and you can use your calculator if you need to. So that's the slope of our tangent line, which, by the way, answers part C down at the bottom. It says use a graphing utility to get the slope, or using some derivative thing, and it says round it. So do 5/3, divide that, and then round it to 2 decimal places. I think it's like 1.67 or something. That's answering part C. But in part A, it says what's the equation of the tangent line, which means I need the slope and that point negative 1, 5 to put in the equation. And so I'm going to put in the 0.5, negative 1, 5/3 in their appropriate places, solve for y. You don't have to I guess you could probably write it in a number of ways, but I went ahead and add 5 to both sides, distributed the 5/3, as you can see right here, and then combined the 5/3 by making 5 15/3, and I got 5/3 x plus 20/3. Hope that gets you over the hump with that one, and email if you have other questions.